Alrighty, so in section 5.4, we'll be writing linear equations in standard form. So up to this point, we've been able to write equations and functions in two different ways. One, which is slope-intercept form, which can be identified as y equals mx plus b. We just recently shown you how to write point slope form, which is y minus y1 equals m times quantity x minus x1. And today I'm going to show you how to write equations in standard form. Standard form is ax plus by equals c. Now there are some stipulations that have to work for standard form to be operational. One is that a, b, and c are real numbers, and a and b are not both 0. So here are some examples. Well, at least the example 1 is I want to be able to write equivalent equations in standard form. Now, if you look at example A, we have a equation that is already in standard form, which is 2x minus 6y equals 4. Now, what I'm looking for is values that are equivalent to that. So for number 1, I want to find a equivalent equation to our example that is multiplied by 2. So for number 1, what I'm looking for is to, when I say multiply by 2, that means I'm going to multiply every value that's in the equation by 2. Thus, that'll give us an equivalent equation. So I'm going to multiply the whole equation by 2. So then if I distribute the entire 2 to the entire equation, that'll give me 4x minus 12y equals 8. So for number 2, I'm asking to find the equivalent equation if you were to multiply it by 3. Same rules apply. And we're going to multiply every number by 3. So it would be 6x minus 18y equals 12. And for the third one, I want to multiply by 0.5, or 1/2. So for our example, we would come up with x minus 3y equals 2. So that's how you write equivalent equations in standard form. Example 2, I want to write an equation in standard form of the line that passes through a given point and has a slope of m. So I think we've gotten pretty familiar with writing equations in slope-intercept form. We probably not as well practiced in point-slope form, but these equations we want to write them in standard form. So first step is I want to first put it in point-slope form. So let's remember what the equation is for point-slope form. So it's y minus y1 equals m times the quantity x minus x1. So here's what you do. Let's put it now in point-slope form using the coordinates -3, 2, and the slope 1. So if I were to write this in point-slope form, it would look like this. Y minus 2 equals 1 times the quantity x plus 3. Because we have a -3 in our x value. We just change the sign in our point-slope form. So now we have it in point slope form, but I want to get it in standard form. So here's how we do that. First thing I want to do is I want to distribute that 1 into our parentheses, so then it gives us me y minus 2 equals x plus 3. Now what I want to do is I want to get that x value on the other side of the equal sign. We can do that by subtracting the x to both sides, which then gives me a negative x plus y minus 2 equals 3. Then the last thing is I want to take that 2 and put it over to the right hand side of the equal sign. So I'm going to add both sides by 2, which gives me negative x plus y equals 5. Now we are in standard form, where my a is a negative 1 and my b is 1. Let's give b a try. So our coordinates are at 0, 5, and our slope is at negative 2. So first thing, just like in example A, we're going to put it in point slope form. So if we're going to put it in point slope form, it looks like this. Y minus 5 equals negative 2 times x minus 0. So I'm going to distribute that negative 2 into the parentheses. So I got y minus 5 equals negative 2x. Now, what I want to do is I want to move that negative 2x to the left-hand side of the equal sign. So it gives me 2x plus y minus 5 equals 0. Now I just want to move that negative 5 over to the right. So I'm going to add 5 to both sides, which then gives me 2x plus y equals 5. And now we're in standard form where our a equals 2 and our b equals 1. Now, there may be some examples where they just give you 2 coordinates. So we'd have to find the slope. So once you find the slope, you would use our equation for the slope, m equals y2 minus y1 over x2 minus x1. And then you just use the same steps that we did for examples A and B. For examples 3, they want you to write equations of horizontal and vertical lines that passes through a given point. So I need some more room. Let's extend the page a little bit. There you go. I like that. Alright, so let's look at A. We're at coordinates 3, 2. So let's just make a graph. And if I were to put I was going to plot 3, 2. Let's say like this here, 1, 2, 3, and then 1, 2. So that is where 3, 2 would be located. So now they want you to write equations of vertical and horizontal lines. So that means that here's a vertical line that passes through that point, and then here is a horizontal line that passes through that point. So if I were to write an equation for the vertical line always starts out with x equals. Now it's just a matter of plugging in which value for that line to be. And since it crosses at 3, it's going to be x equals 3. Now, for our horizontal line, it's crossing through the y-axis, so that's going to be a y equals. And it crosses through at 2. So for A, we're the coordinates of 3, 2. The 2 equations that are vertical and horizontal lines that pass through that point are x equals 3 and y equals 2. So for B, let's not even use a graph. Let's just see if we can figure it out without using a graph. So first off, let's look at the vertical line. We know that the vertical line will be an x equals. And our x coordinate is -1, so our vertical line would be x equals -1. For the horizontal line, it will be a y equals. And since our y coordinate is 3, our horizontal line will be y equals 3. For C, again, vertical line, it will be x equals -1. And for a horizontal line, our y equals 4. Last thing is we want to find the missing coefficient in the equation of the line that passes through the given point. Then I want to write the complete equation. So for A, I have ax plus 3y equals 5. So the missing coefficient right here is I need to find what A is. And they give us two coordinates. They give us coordinates 2, -1. So in order to find what A equals, I'm going to substitute in our coordinates that are given to us and plugging them into our x and y values in the equation. So I have A times by 2 plus 3 times by -1 equals 5. So now what we're going to do is I still got A times 2. I got plus, what is it, 3 times a -1, which gives me a -3 equals 5. Now what I want to do is I'm going to, since that's a negative, I want to add 3 to both sides, which gives me my A times 2 equals 8. Now I want to divide by 2, so my A equals 4. So my missing coefficient was A equals 4. Now the second part of our question is they want us to then write the complete equation. So now that I know that A equals 4, I can rewrite this as 4x plus 3y equals 5. And that completes the question. Let's look at B. B, we have -x plus by equals 10 with coordinates -2, -2. So we know what A is. We know A is -1. It doesn't show that, but we could easily write it as -1x plus by equals 10. So now if we just take our values for x and y, and we can then solve for B. So if we take our -2 plus b times it by -2 equals 10. First thing we have to do is now we're going to solve for b. So the first thing we'll do is we'll add 2 to both sides, cancel each other out, which b times -2 equals 12. Now the last thing we have to do is divide both sides by -2, which then b equals a -6. Or I'm sorry. Yeah, -6. So since we have a -6, that's our missing coefficient. So to rewrite this, it is -x minus 6y equals 10. And that completes the lesson. I hope this helps. Until next time.